Right, welcome back to another TempleOS video. So this is the Stanford Bunny. Actually, it's a low poly version of the Stanford Bunny. And obviously this is not TempleOS. This is ParaView in Windows. But this is a 3D model viewer. And what I'm going to do is make something like this in TempleOS. So we're going to try to make a wireframe general purpose 3D model viewer. So I'm going to start up TempleOS. Here we go. Full screen. Wait, and close out the autocomplete window, just because it's a little bit annoying. Okay, don't know how I typed that. Anyway, right, so before I get into that, so I did the boring part off screen. I made the STL file reader, just reading the 3D model file from disk into memory. I did that boring part off screen, and that's here on Git. And one thing that I'd like to point out about whole EC files on TempleOS is that indentation is stored as markup in the file. So ID2 means indent by 2. There's another one. And ID -2 means unindent, back in the other direction. So that's markup in the file, and it doesn't display correctly on GitHub, obviously, or in basically any other file editor outside of TempleOS. So this is indented, it just doesn't display like that. Anyway, back to TempleOS. So I'm going to go full screen for most of this. Anyway, this is the file reader. It's pretty boring. All it does is read the STL file. And this isn't really part of reading, but it also gets the bounding box of the STL because that's going to be useful for displaying this in a graphical window, right? We don't want a huge file to be like zoomed in all the way, and we don't want a very small file to take up just like 1 pixel. We want to be able to zoom depending on the size of the STL so that the model fills up the screen just the right amount. And then I'm going to take the tetrahedron thing that I did in the last video, and I'm going to paste that into the STL viewer to view a whole STL instead of just a stupid little tetrahedron. So let's go and open up that tetrahedron viewer. This is it. This is what we did in the last video, so watch that if you need to get up to speed. And I'm basically just going to copy this into the STL viewer. So yeah, let's put it. I have a note to myself to do graphics, so we're going to fill that out. And let's basically copy the whole tetrahedron viewer. Copy and paste. Although I don't actually want to call tet out in the global scope. And if I run this, it should still compile, and it's just going to read an STL but not do anything with it. Yeah, there we go. And now I can start to plug in the graphics. So if I call tet here, that should just read an STL, but then draw the tetrahedron instead, like we did last time. Yeah, there we go. So this is what I was talking about. So the tetrahedron is off-center, right? This window is taking up the lower 2/3 of my screen, but it goes all the way across from left to right. But it's kind of like all in the left half of the screen. So if I can figure out how to get the screen dimensions, I should be able to fix that. But first, let's make this work on an STL instead of a stupid little tetrahedron. So I'm returning an integer and using that to handle errors. Nope, not that. Just pasted. I did not mean to paste. Okay. Really? You kept the parentheses, but undo in TempleOS editor is a little bit weird. Like, you hit undo once and you don't really know how many keystrokes it's going to undo. It's kind of just a roll of the dice. And I wanted to copy that, not paste it. Okay, I'm actually going to go out of full screen because the aspect ratio is a little bit stretched out. So zoom to fit, and then that looks a little bit better. The problem is the mouse doesn't work correctly. I can't go all the way down, so I'll just have to stick to arrow keys only. So I might go back to full screen later, but at least the text has the correct aspect ratio this way. So first of all, STL view doesn't exist. So let's plug that into the tetrahedron renderer. No, this is already named STL view. I'm going to call it STL render. And it has to return something. And this is actually not indented. This is just indented with spaces. But I'm going to fix that later, and I'll just use spaces for now, even though it's annoying. Actually, I might as well. So indent and then unindent. Where did my indentation go? Okay, that's what I wanted. Okay, so now this has to return something. Yeah, indentation is really annoying in this editor. If you try to do spaces, there's no way to indent a whole block of text with spaces that I figured out. So the best way to do it is Control-I and Control-Shift-I. But then you get into trouble if some things are indented with spaces and some things aren't. So this should still compile, I hope. I spelled that wrong. Now that should compile. There we go. And then instead of draw tet, we're going to call this STL draw. And then so STL draw is assigned to draw it as a callback. And yeah, that doesn't compile. Invalid lval 329. Right. Draw, not view. And there we go. So obviously this is still drawing a tetrahedron, but I just want to compile this at every step of the process to make sure that it still works. And I'm going to close this window on the right because I don't really need that. And we're going to go into this directory because this is where I'm actually running. This is what I just saved at 11:45, 7:45. Time zones are off, but I haven't configured the system to get the correct time zone yet. So now instead of this code to draw an STL, to draw a tetrahedron, I'm going to make this draw the STL. So that's going to have to loop through the vertices, and the first thing is I need to visualize the STL class, which is defined where is it? Yeah, it's defined right here. So it has the number of vertices, NV, and then a pointer to an array of floats, which is size 3 times NV. The 3 is because there are X, Y, and Z coordinates for each vertex. So it's 3 times as big as the number of vertices. And the thing is, STL draw is passed as a callback. Right, so this STL draw function can only take a CTask pointer and a CDC pointer because it's assigned to the draw it function. So I can't add any other arguments to this. I can't add an STL argument. So what I'm going to do is make a global variable. Let's follow that convention of GLBL. I think we have null. Yeah, so that's syntax highlighted, and that lets me know that null is actually a keyword. I'm not just making that up. And then I need to assign that in here. Right, so STL render needs to take an argument. That's the address of the STL pointer. And I'm going to copy that into the global variable. I'm trying to avoid global variables except where I absolutely need to, so I can limit the scope to inside this STL render function. So I can assign it right here. They're both pointers, so I don't need the address of it or anything like that. And then after I'm done with it, I'm going to set it back to null, just to be safe. And then inside the STL function, I can grab that. And give it a short name, S, because I don't want to type too much. It should still compile. Nope. Right. 306 STL. Yeah, and then the next problem is Terry has already used S for scale. So let's call that SC instead of S because I'm using S for the STL. Then where else does that come up? Let's search for it. So Control F, search for S, delete the last thing that I searched for, and I only want whole words. I don't want just the S at the beginning of a word. So that S is still S. That's not working because there's an extra space. this is the scale. And this is just basically boilerplate copied and pasted from the tetrahedron example, which was originally copied and pasted from the box demo that's built into the operating system. So that's it. Oh, I think I crashed. There's no type checking in TempleOS, by the way. So if you pass a float to something that expects some type of class or some other type, it doesn't work. It'll compile, it just won't run. So what did I do? Do some debugging. Just to make sure I'm passing the right things in the right places. And this is a pointer, so I have to use the arrow instead of the dot. Well, obviously that's still going to crash. I meant to put in a return to stop it before it crashes. This is going to take a lot of iterations. I'm going to crash the operating system pretty frequently in this video. Come on. Yeah. Okay, so everything is correct until that point. Oh, come on, man. I searched for this. How did I miss that one? Let me search again. I had S instead of SC there. So I meant to replace that before. Let me search for it again. Just to make sure I didn't miss another one. That's the STL, that's the STL. Yeah, I think that should be okay. Okay, there we go. Yeah, so when you pass an STL for something that's supposed to be a float, you're going to have a bad time because there's no type checking in the operating system. Let's add a little white space here. Okay, so back to the point at hand. Yeah, while we're at it, let's double check that this is getting passed correctly in here too. Oh. Okay, yeah, so that messes up the window a lot. Gonna have to reboot. it didn't actually crash the operating system, but when you try to print a string in the middle of graphical rendering, apparently that's what happens. So thank you, Terry. I'm not going to be the one to question divine intelligence. All right, let's get rid of that. Okay, my window is not messed up now. Great. So instead of drawing a tetrahedron now, we get to do the fun part. So I'm going to comment out tetrahedron stuff. I find C comments to be a little more convenient to commenting huge blocks because there's not an easy way to block insert the / for the C++ style comments. Anyway, right, so I'm going to loop through every triangle, and that's important. I'm looping through the triangles, not the vertices. So that's going to dictate the size of the loop. I need an integer. And this is an example of what not to do. And we're looping through every vertex, so that's NV. But it's 3 times that big because there's X, Y, and Z. And then I want to loop by triangle, so every time in the loop I want to add 9. I can make this window a little bit bigger. Notice the word wrapping is working now. Okay, and this is not going to compile because, fun fact, you can't declare the integer inside the header of the loop. You have to declare the integer ahead of time. And that says, yeah, missing semicolon at 311. So a little bit of a not helpful error. I don't think I'm missing a semicolon. But if I declare that I ahead of time, yeah, that compiles now. It doesn't do anything because I commented out the tetrahedron rendering, and I haven't implemented the STL rendering yet. Now, I basically want to do this. I want to draw 3 lines for each triangle. And for that, I need the index of the x coordinate of each each vertex of the triangle. So that's going to be, because this is incrementing by 9, that's going to be I and I plus 3 and I plus 6. So let's call those A, B, and C. Because the style of TempleOS is short variable names, because we're not supposed to type too much. And that's good, because I can't type very fast on a QWERTY keyboard anyway. So A is just going to be I, or I plus 0. And then plus 3 and plus 6. And then this takes the DC, and then the 2 points. So that's going to be, so if you look at the class, Holy C has classes, not structs. But a Holy C class is basically a C struct. Everything is public by default. So this float array is called V, and that's a float 64. So that's what I need to plot as a line. So V, and then the index is A, but this is a float, and I need to pass a pointer to my line, right? Because this takes pointer A and pointer B. So I need the address of all this. So that should do it. So that's A. So the first line is going to be from A to B. So I think that should be it. We'll do the other two lines next. So this should just be part of the bunny if this compiles. Yeah. So it's actually 2/3 of the bunny. Statistically, it's roughly about 2/3, probably, because every triangle in the STL, or every edge in the STL, is shared by two triangles. So I'm looping through all the triangles and plotting 1 out of 3 edges, but that's going to give me 2/3 of every edges because every edge is shared. At least it should be in a watertight STL. So that's 2/3 of it. And then if I plot the rest of them, that's the whole bunny. These lines are actually kind of thick. So I'm going to change this thickness to 1. All right, now the next thing is the scaling. So this bunny is kind of small, right? The example tetrahedron viewer and the cube viewer, they blow up to about the whole size of the screen. So I'd like to scale this to make it bigger. And there are a couple ways that we can scale that. One way is we could use this scaling factor here and set it to something other than 1, plus or minus like 0.8, 0.4, or whatever the range of this scaling factor is. But the other thing is the way that graphics are implemented here. So if I bring up the help menu with Control F1 and I put my cursor at the end of GR line 3, I can just jump to the definition. If this window isn't going to flash all the time, I should be able to jump to that. Straight in the kernel source code. Yeah, so this is in the Atom directory, so this is part of the operating system. And this takes I64s, not floats. Yeah, so there's a comment in here somewhere. Yeah, it must be another graphic function, not graphic primitives. But apparently the graphics are implemented in fixed point, not floating point. So that's why this takes integers. So instead of scaling it with the mat 4x4 scale, I'm just going to scale the whole STL. And I already have a function for that. To scale the whole STL. So I'm just going to call this before I do the rendering. And the arguments are first the scaling factor and then the STL. So I'm just going to do that after I load and before I render. I don't know what the right scaling factor is to begin with. Let's try 20. Just to see how that looks. That's a little bit too big. That's way too big, actually. Maybe 5. Yeah, 5 is okay. The other thing is this bunny is rotating around the origin, but the origin isn't in the middle of the bunny. So I also want to translate this before the rotations. And for the translations, I'm just going to try to use a built-in operating system function. So there's identity equation, which does nothing. and then there's ZXZ rotations, and then there's scaling. So there should be a translation too. Bring up the help menu, 4x4. Yeah, and so we have ident translation. Sorry, my webcam is in the way, so I have to lean up to get a view of that part of the screen. So, yeah, here's the comment. Yeah, so this uses fixed point, and it does some weird bit shifting. So I don't totally understand how this works, but I don't need to understand the implementation for now. I just need to be able to use it to translate. So there's a translation EQ, which sets the translation, and then there's translation add, which adds to the translation. So I'm not really sure which one of these I need to use, but we can just try both and use the one that works. So EQ, and then autocomplete. No. So F1. No. What did I just do? Is it Control F1? Yeah. Okay, so Control F1 auto-completed that for me, so I didn't have to type. And then I can close that window for now. This takes R, X, Y, and Z. So first is R. Yeah, it's structured just like this, except it has 2 extra arguments. And then the translation. So if I go back to the STL class, I've already saved the center of the STL as metadata. So I have the bounding box and the center and the radius for some definition of the radius. So I want to translate by CX, CY, and CZ. Let's add a line break. Oh, I also have the scaling factor. So I scaled first, and then I'm translating. So I need to scale it. So I need to translate it by 5 times the center, at least the way that I have this implemented. So this is not going to be right. Yeah, so that's still not right. It's still rotating about some other point. So let's make this another global variable. Actually, let's do it the right way. So what I should do is inside this function, I already have a to-do note for myself. It should modify the bounds, the radius, and the center. I'll take care of the bounds later, but I'll at least get the radius and the center for now, because I need those to scale and translate the graphics. So just going to multiply everything by the scaling factor. Oh. Right, this is C. I'm used to Fortran, or I actually have to do CX equals F times CX. But this is much easier to do. That's the wrong thing. This is much easier to do in C. And Holy C. You know what? I might as well get the bounds too while I'm at it. All right, and then I think this translation should work now. Oh, I'm translating by a positive amount, but I want to move the center to the origin. So I actually need to negate all of these. Yeah, and there it is. So it's rotating about its center. That's what I wanted to fix there. The other problem is that the 3D model is not centered in the middle of this graphical window. So to fix that, I think we have some magic numbers here. Yep, there are some magic numbers from the example here, 200. I guess that's in pixel units. So it should probably be, well, let's see what happens if we make it 0. So now it's even worse. What happens if I make it 400? Now it's on the other side of the screen. So I think I want this to be half of the screen dimensions. So TempleOS is like 640 by 480. So I want to make that 320 by, I think 200 is about good for Y. Yeah, Y is roughly already centered. Right, so what I'd like to do eventually is figure out the actual window size and do this automatically instead of having these hard-coded magic numbers. But this is the way that the example worked, so I'm just going to leave that like this for now. What I will do is I'll get rid of this commented out tetrahedron code. What happened to the indentation? Oh, there we go. This 5. Right, so I want to scale this based on the model size and not just have this as a hard-coded 5. So if the model is big, I want to scale it down, and if it's small, I want to scale it up. So what I'm going to do here is divide by the model radius. And then I'll probably need to adjust this 5 vector by trial and error. Oh, yep. I know what I did wrong. That one should actually be s.r because s is not a pointer in this class, but I screwed up and I crashed the operating system again. So let's fix that. Right, this should be s.r. And I think that should work. So now it's really small, so I need to adjust 5. Let's try 200. Yeah, that's okay. Maybe 300 actually. Anyway, I'm not going to waste too much time doing this by trial and error. I should be able to get the screen dimensions and do that totally automatically without having anything hard-coded. But the next thing I want to do is try another model. So to do that, I need to download another STL. So Benchy, that's what I wanted. This might have too many triangles. I'm a little bit concerned about that. The other thing I can try, $10 megabytes. Yeah, it's kind of a lot. The other thing is, yeah, it's 10 megabytes already, even as a binary STL. So yeah, this is insane. I'm gonna do the teapot instead. So this is more triangles than the bunny, but it's not insane like the boat. So the first thing I need to do is, this is binary. I've only implemented an ASCII STL reader. So I need to convert this from binary to ASCII in ParaView. And the way you do that is File, Save, I have to select it, File, Save Data. Yeah, that's the right folder. Okay, and then change this from binary to ASCII. And then right, this is ASCII now, this is not binary. So that's what I need for TempleOS. And to transfer that, I need to shut down TempleOS. And then I'm using imdisk or imdisk. I don't know how to pronounce this. I'm using imdisk virtual disk driver to attach the TempleOS virtual disk. It has two partitions. There's a C drive and a D drive. I really only need to work with the C drive. And then what this does is it mounts it as the letter H drive on Windows. So then what I can do is copy the teapot to there. So that should be in there now. Come on, it's already done. Now I have to remove the disk before I can start TempleOS again, and now I can start TempleOS. Teapot should be in there now. So for some reason, Windows is a case insensitive file system. So even though I have lowercase teapot, it now got renamed to uppercase teapot. So I'm kind of just stuck with that. Mouse problems. There we go. So now I can try out the teapot instead of the bunny. there we go. There's the Utah teapot on TempleOS. So I think that's enough for today. The next things that I'd like to do is add mouse controls. So obviously this thing is just rotating and zooming in and out all on its own. So I'd like to add mouse controls so that I can control the movement of the teapot. And then the other thing that I'd like to do is instead of wireframe graphics, I'd like to visualize this as a solid body with opaque polygons. But I'll have to figure that out some other time. Well, since I'm still recording, I'm probably going to edit this out. But yeah, I want to mount this again. And then copy from TempleOS to my Git repository. And then, yeah, that's everything that we just did. Lots of weird, those are the Greek characters. I don't know what those meta characters are. Yeah, the TempleOS editor is weird. And push that. So there it is. Yeah, I think that's enough for today. So I'll catch you next time.